This video we will learn direction of TEM wave and its relation with the direction of its components, that is electric field and magnetic field components. Means how we can determine the direction of a TEM wave using electric field and magnetic field component, and how these three things are related, like direction of TEM wave, electric field component and a magnetic field component. So I have taken a question from previous year GATE exam that reveals this concept, and the question is, which of the following field patterns represent a TEM wave traveling in the positive x direction? So the wave direction is given here, that is positive x direction, and here the different combination for electric field and magnetic field is given. So we will try to determine the TEM wave direction using these components, and once we will get the TEM direction, we will check it whether it is in x direction or not. If it is in positive x direction, then that will be the correct option. So first of all, we will learn the relation between the TEM wave direction and these field components, means its field component direction. So here I start. So direction of TEM wave and its field components are related as in this way. Vector E is electric field component of the TEM wave, vector H is the magnetic field component of the TEM wave, and vector K is the direction, or we can say the wave vector. Here I have written electric field, magnetic field, and it is the wave number vector that is in the same direction in which TEM wave travels. So it reveals the direction of TEM wave. Okay. So these are cyclic vectors in anti-clockwise direction. So here I have drawn a cycle. Vector E is here, vector H here, vector K here. So once we multiply vector E, cross multiplication always will be there. Once we multiply vector E with vector H, we will get vector K. When vector H will be multiplied with vector K, we will get vector E, and similarly. So these are the relation that we will get if vector A means direction we are taking only, as we are concerned about the direction only. So vector AE cross vector AH will give vector AK, vector AH cross vector AK will give vector AE, and similarly vector AK cross vector AE will give vector AH. So in this way, this is cyclic, and we can determine any of the direction by using the rest two. Okay, if we will go clockwise in the opposite direction to that we are going earlier. So if we are going clockwise, then what will happen? We will just put a minus there. Vector AE cross vector AK will result in minus vector H. Similarly, vector K cross vector H will result in minus of this, and similarly this cross this will result of minus in this. So these are the relation that we must know how these in the two components direction, the two component direction and the wave direction related. So now we will try to solve the question. So in the given question, we will go through the options and check which one gives the direction of wave as a positive of x direction. So here we have the wave direction, vector AK equals to vector AX. This is wave vector direction. So we will check one by one. First, for the option A, the vector AK equals to vector AE cross vector AH. So vector AE is y cap and vector AH is minus z cap. So y cap cross z cap will result in x cap. So negative of this. Again we will solve this one. Negative y cap into negative z cap will result x cap, and similarly all other options we will check. So here we can check that this option gives the answer x cap. So this is the only option that matches, and so this will be the correct option. So in this way we can do the questions related to this concept, and very easy concept it is. So we have to just learn it is that E, H, K are cyclic, means here in this way we can go. E cross H will be result in K, K cross E result in H, and so on. So this is the only concept that will be used in solving this question. In the coming days, I will come with some other videos and with some better concepts. Thank you so much for watching.